Hello, I just wanted to take a minute to cover some of the details of graphic displays as they pertain to single case research. Let's start by answering the question, what are the purposes and benefits of graphic displays? Well, plotting behavior measures on a graph regularly, even daily, gives researchers and teachers immediate access to ongoing visual analysis of the student's behavior. So this allows for database decisions to be responsive. Interpretation of graphed data takes less time than in a group experimental design, and it has no predetermined arbitrary level of significance, whether it's large or small. We get to actually look at the data to determine whether the changes are significant. We also can note any variability or overlapping data that are obvious. So visual analysis remains a conservative method of judging the significance. That meaning and significance of the data can be judged by individuals reviewing the data, parents, teachers, and students alike. Graph data allows for student self-evaluation, maybe even the student self-graphs, and this has been shown in itself to improve behavior. And lastly, graphs facilitate communication and comprehension. So let's use it to help students, parents, and teachers alike. Now I have another question for you. What are the characteristics of those graphic displays? I really want you to use graphs to display your data and to analyze your data. But what is the appropriate way to do so? Well, I'm going to give you the appropriate way for single case research publication. However, it will be just as easy for you to follow these guidelines in an applied practice in your classroom. So what do we have first? We have the vertical and horizontal axes, sometimes called the ordinate and the abscissa. But we need to make sure we have labels for these. The vertical axis depicts the dependent variable or the target behavior, so we need to be sure to indicate what is changing. The horizontal axis depicts the time sequence of the study. And as you know, with single case research, over time, we change conditions between baseline, or the treatment as usual condition, and the intervention condition. And with replications of effect across those conditions, we can show a functional relation between the independent variable and the dependent variable. Let's take a look. Here we have it. Our dependent variable is percent spelled correctly. And we have a cross time here. Next, we need to have our conditions. The conditions are the phases of the study, baseline or intervention, and it's usually separated by a solid line. Here we have baseline, condition change line, intervention. Data points obviously have to be on our line graph. We use black solid circles. Other shapes can be used if there's more than one dependent variable being plotted on the same graph. See here, data points here and data points there. For publication, they need to be black. However, Excel will automatically populate it in blue. Then we need a caption describing what's presented in the graph. In addition, we'll need to scale it so that it's not skewing the data. You read about that in the text. Let's look at this example. Here we have our final graph. We have our y-axis, which depicts our dependent variable, percent spelled correctly. It's scaled to 100% and it is labeled. Here we have our x-axis, which gives us our time series across different conditions. Our baseline condition, the condition change line, and our intervention condition. We've a caption for our graph, and it's clearly presented that the intervention, it did increase Johnny's spelling scores to a mastery level for 3 consistent days. So there's a lot to be learned from this graphic. Did the intervention increase the percent of words spelled correctly? You tell me.
Well, the truth is, we can't tell if our intervention is responsible for the change in Johnny's spelling. Why? We have not considered confounding variables. We have not considered that this is only correlational data. An A-B design can give us some information. It can show us that Johnny's spelling has changed, but it does not show us or tell us that it was the intervention that in fact changed Johnny's spelling behavior. In order to increase the confidence in our intervention as the causal agent in Johnny's spelling, we need to resolve the issue of replication of effect, the issue of prediction, verification, and replication. This can be easily described with an A-B withdrawal design. After a stable baseline condition, one would predict that this pattern of behavior from session 1, 2, and 3 would continue and remain the same if the intervention had no effect or if no intervention was put in place. However, you would predict that if the constant time delay teaching procedure has an effect, a different pattern would emerge. Verification occurs first when the change from baseline to intervention conditions result in a change in the student responding. But then a verification occurs when we return to the baseline condition again and data return to previous baseline levels. Finally, our replication occurs when the second phase or condition of constant time delay is put into place, and we see a similar response pattern as in the previous intervention condition. So this is what we call the affirmation of the consequent, where we have prediction, verification, and replication. Some may say, in simple terms, we need these 3 replications of effect to show experimental control and a functional relation between our intervention, our independent variable, which is our constant time delay teaching procedure, and the dependent variable, which is percentage of words spelled correctly. So it is important that we not express that there is some kind of causal agent in an A-B design when it comes to research and showing that an intervention most likely is the reason for behavior change. We need our 3 replications of effect.
All right, there you have it. You can see my tutorial on creating graphs in the next video. Thanks.